All right, so this will be example 2 for this review session for homework or for exam number 1. And this example is going to be Alexander problem 115, so 115. All right, and I'm given a current, which is a function of t, and a voltage, which is 10 times the derivative of current, and I'm asked to find a few different things. The first is to find the charge. Now, I have the current, so I know that Q is equal to the integral of I dt, all right, which is equal to the integral of 6e to the minus 2t between 0 and 2 dt. And I know, by the way, this is 6 milliamps, so this better be accounted for. And when I evaluate this, I should get negative 0.006 over 2, all right, because I'm integrating e to the minus 2t between 0 and 2, all right, which is equal to negative 0.003 multiplied by e to the minus 4 minus e to the 0. And we know that e to the 0 is equal to 1. All right, so it's going to equal to negative 0.003 multiplied by negative 0.982, which is equal to 2.95 millicoulombs. All right, so it's approximately a third of approximately 1/3 of my 0.98 millicoulombs. And I just want to clean up this 9 so there is not any confusion. This is 2.95 millicoulombs. All right, now we'll do part B quickly. I asked for the power absorbed. All right, and I know that P is equal V times I, and I have I, so now I just need V. So first find V, which is equal to 10 di dt, which is equal to 10 times negative 0.012 e to the minus 2t. All right, that's the derivative of I. All right, so this is I in milliamps. If I take the derivative, the minus 2 comes out, so I get negative 12. And then it stays in milli, so I want to make sure this stays in milli, just to make sure my units are okay. All right, so this is equal to negative 0.12 e to the minus 2t volts. All right, so then all I've got to do is take power times, power is equal voltage times current, which is equal to negative 0.12 e to the minus 2t multiplied by 0.006 e to the minus 2t, which is equal to negative 720 e to the minus 4t microwatts. All right, milli times milli is micro. All right, and now finally part C. I just want to find the energy absorbed, and I do that by integrating power with respect to time. So W is going to be the integral from 0 to 3 of this power, which I found. And this is in microwatts. So it's going to be, well, since this is in microwatts, that means in milli, it's going to be 0.72. All right, but what I can do here is, basically make sure that I have this right. So this is going to be negative 720 times 10 to the minus 6 e to the minus 4t dt, which is going to equal to negative 720 times 10 to the minus 6 integral 0 to 3 of e to the minus 4t 4t dt. Alright, so now w is going to be minus 720 over minus 4 times 10 to the minus 6 e to the minus 4t evaluated between 0 and 3, which turns out is equal to 180 times 10 to the minus 6 times e to the minus 12 minus 1, which is e to the 0. And e to the minus 12 is really, really close to 0. So that means that my value for w is going to be negative 180 microjoules. All right, and that's the solution for example 2.